guys, Assalamualaikum warahmatullahi wabarakatuh. Very good morning. Okay, today we would like to talk about BMFG 4623 for chapter Present Worth Analysis. For your information, this is our fourth chapter for engineering economy. So, the learning outcomes for today's chapter is to utilize the different present worth or future worth techniques to evaluate and select alternatives. Okay, it is to formulate alternatives where we will find mutually exclusive and independent projects. We define revenues and cost alternatives. Number 2, PW for equal life alternatives, where we will be selecting the best equal life alternatives using present worth analysis. Number 3, PW of different life alternatives. We'll be selecting the best different life alternatives using present worth analysis. FW analysis, we'll be selecting best alternative using future worth analysis, and CC analysis, where we will select the best alternatives using capitalized cost analysis. So here we know that PW is present worth analysis and FW is future worth analysis. There's two things and three things that you need to know: PW, FW, and CC, which is the capitalized cost. As an introduction, an engineering project or alternative is formulated where we want to make a purchase of a product, or we want to develop a process, or we want to provide a service with specified results. Hence, an engineering economic analysis evaluates cash flows and estimates the parameters as initial costs, annual costs, and revenues, non-recurring costs, and possible salvage value over an estimated useful life of a product, process, or services. In this chapter, we will be learning to develop and demonstrate the basic tools and techniques to evaluate one or more alternatives using factors, formulas learned from the previous discussion. In understanding to organize an economic analysis, this chapter begins with a description of independent and mutually exclusive projects as well as revenue and cost alternatives. The two types proposals, economic proposals, that we will be learning in this chapter, first of all, is the ME, or the mutually exclusive alternatives, where only one can be selected and it compete against each other. Or the second economic proposal is the independent project, which is more than one can be selected and it compete only with the end. So what is the end? The end is do nothing, or we don't take any changes at all. It's an ME alternative or independent project to maintain the current approach, no new costs or revenues or savings. Another two types of cash flow estimates that we will learn is the revenue cash flow diagram, where it is an alternative that include estimates of costs, cash outflows, and revenues, cash inflows. Second cash flow is that the cost cash flow, where it gives you alternatives that include only costs, revenues, and savings assumed equal for all alternatives, and it is also known as service alternatives. Righto. So when we're formulating alternatives, we have lots of ideas, information, mandates, experience, plans, and estimates. And amongst others, things are viable, things are not viable. Okay, so how do we compare between the ideas that we have in giving solution for engineering economy? Which one is more economical? That is why we will choose either mutually alternatives or independent project to choose either or both proposals as the solution for our project, process, or services. And the type of cash flow estimates will give you the information on revenue alternatives, and also it gives you the cost alternative in performing the project. Okay, selection of alternatives by present worth is for an alternative shown below, which should be selected if they are mutually exclusive or independent. So what do we have here? We have project ID A, B, C, D with a present worth of $30,000 for A, $12,500 for B, and negative $1,000 for C, and $2,000 for D. Select numerically larger PW. Okay, which is the numerically larger? Which is A. Number B. Select all PW above than 0. Project A, B, and D. So we will omit C because C is negative. The present worth analysis of equal life alternatives. Okay, the present worth P is renamed PW of the alternatives. The present worth method is quite popular in industry because all future costs and revenues are transformed to equivalent monitoring units now, and that is all future cash flow are converted or discounted to present amounts at a specific rate of return, which is the MARR. So this makes it very simple to determine which alternative has the best economic advantage. So MARR is maximum allowed rate of return. All right. The evaluation for one project is PW bigger than 0. It is justified. It's a go-go. For mutually exclusive alternatives, select one with numerically larger PW, and for independent projects, select all with PW bigger than 0. Okay. So thus, for ME, we always go for the largest PW. For independent project, anything that is bigger than PW equals to 0, it is a go-go. Convert all cash flow to PW using MARR and proceed costs by minus sign, receipts by plus signs. Okay, this is how we do with PW analysis with MARR. Okay, this is an example of PW evaluation of equal life. Alternative X has the first cost of $20,000, an operating cost of $9,000 per year, and $5,000 salvage value after 5 years. Alternative Y, so we have two alternatives here, X and Y. Hence, Y will cost about $35,000, which is more than alternative X, with an operating cost of $4,000 per year and a salvage value of $7,000 after 5 years. Taking into account the MARR is 12% per year, we should be selected. So we have two, X or Y. So this is the cash flow diagram for alternative X. You have the first cost $20,000, the operating cost $9,000, and the future salvage value of $5,000. So how do we determine the PW? This is the solution. Negative $20,000 minus $9,000 times present worth factors for P over A plus $5,000 for P over F, and you get a value here, negative $49,606. So how about alternative Y? For alternative Y, okay, this is the cash flow diagram. The cost is negative $35,000, operating cost $4,000, and future worth is $7,000. At MARR 12%, we get a value of 45,447 negative. So which one has a bigger PW? It is Y. Right? So hence, select alternative Y. Example PW evaluation of equal life. Okay, this is a case study of a university lab where a research contractor for in-space fuel cell systems that are hydrogen and methanol based. During lab research, 3 equal service machines need to be evaluated economically. Perform the present worth analysis with the cost shown below. The MARR is 10% per year. So we have electric powered and gas powered. These are the figures, the first cost, the annual operating cost, the salvage value, and the life, which is the end. Okay, sorry, we have another solar power. So we'll be comparing between three alternatives here. So the answer from the PW equivalence cash flow diagram we did previously, we found out that present worth for electrical is negative $9,208. PW for gas is negative $7,071, and PW for solar is negative 6,222. So we choose PW, the biggest, isn't it? So the solar powered machine is selected since PW of its cost is the lowest. Okay, it has the numerically largest PW. Okay, example of PW evaluation equal life. Example of electric powered cash flow diagram. Okay, so for electric powered, we have for the first cost of $45,900 as the operating cost and $2,000 as the salvage value after 8 years, and the life is 8. So the solution, okay, the solution is PW minus 45. Yeah, this is similar to this one we've shown you earlier. It should be around like this. Okay, present worth analysis of different life alternatives. The PW of the alternative must be compared with same number of years and must end at the same time to satisfy equal severity requirement. LCM, least common multiple, is when we compare PW alternatives over a period time equal to LCM of their estimated lives. Okay, study period, we compare the PW of alternatives using specified study period of years. This approach does not necessarily consider the useful life of an alternative. The study period is also called as the planning horizon. And as a rule of thumb, LCM procedure is used unless otherwise specified. And this is a fundamentally engineering economics that LCM is to be counted in analysis unless specified, okay, unless informed. So assumptions of LCM approach is that the service provided is needed over the LCM or more years. Selected alternatives can be repeated over each life cycle of LCM in exactly the same manner. Cash flow estimates are the same for each life cycle, change in exact accord with the inflation or deflation rate. Okay, LCM approach makes the cash flow estimates extend to the same period as required. For example, lives for 3 or 4 years are compared over 12-year period. The first cost of an alternative is reinvested at the beginning of each life cycle. An estimated salvage value is accounted for at the end of each life cycle when calculating for PW values over the LCM periods. This is an example of different life of alternatives. So when we see that the life here will be different, okay, compare the machine below using present worth analysis at 10% per year. So LCM for 6 years, the solution, okay, find the LCM for 6 years, repurchase A after 3 years. Go for machine A, all right, with n equals to 3, we calculate for PW, negative 20,000 minus 9,000 P of A, 10% 6, okay, minus 16,000 P of F, okay, Y 16,000 is $20,000 minus 4,000, the salvage value after year 3 because you want to repurchase, plus 4,000 because this is a salvage value equals to negative 68,000. For PWB, we have negative $30,000 minus 7,000, P of A 10% for 6 years. Okay, 6,000 plus 6,000, the salvage value, P of F 10% minus 6. Okay, so when we have the numbers, this is not moving. Why is it? Okay, let's get out of this slide. We got this figure, alternative B, where we find that alternative B is much more profitable as compared to alternative A. So now next we will move to next slide over here. Okay, example of PW alternatives A and B. This is example how the cash flow diagram looks like. Okay, for you to have the better understanding. When we have the second cycle of the third year, we repurchase and we calculate this for the next 3 years of second life cycle. Okay, for alternative B, we have up to stretch of n equals to 6. So the next slide is PW evaluation using a study period. Once study period is specified, all cash flows after this time are ignored. The salvage values is the estimated market value at the end of the study period. Short study periods are often defined by management when business goals are short-term. Study periods are commonly used in equipment replacement analysis. Okay, for example, a study period for two alternatives, machine A and machine B. Okay, we have machine A with two different life years, which is machine A has 3, n equals to 3, and B is n equals to 6. The first cost is negative $20,000, annual cost $9,000, salvage value $4,000. And for machine B, the first cost is negative $30,000, the annual cost is negative $7,000, the salvage value after 6 years is $6,000, the salvage value for after 3 years is $10,000 for machine B. The solution is study period 3 years, disregard all estimates after 3 years. For PWA, for using study period, negative $20,000 minus $9,000, P of A 10 to 3 plus $4,000, P of F negative $39,376. For PWB is negative $30,000 minus the salvage value, 7,000. The operating cost value, negative $7,000, P of A 10%, n equals to 3 plus 10,000, P of F 10%, 3 years. Okay, and the marginally select, because we get the value negative 39,895,000. Marginally, we have to select A because A is much more economical. Okay, then LCM for 6 years. Okay, this is because we use study period PW evaluation. Okay, example of period PW evaluation. The cash flow after year 3 are ignored. Okay, this is what it meant by using study period evaluation rather than using the previous method that we use in previously using these alternatives. Okay, different life alternatives. There's two methods of using, and it all depends on the question given to you later in your exercises and your examinations. Okay, we have next is different life alternatives. FKP Home Builders in Berhad plans to repurchase new cut and finish equipment. The two manufacturers offered an estimate below. Vendor A, the first cost is $15,000 and operating cost $3,500, and salvage value is $1,000. Life years, not 6 years. Whilst the first cost for vendor B is $80,000. Operating cost, yearly cost is $3,100. And the salvage value is $2,000. And the N is equals to 9. A, you are asked to analyze which vendor should be selected on the basis of present worth comparison if the MARR is 15% per year. And B, the FKP Home Builders Neighborhood has a standard practice of evaluating all options over a 5-year period. If a study period of 5 years is used and salvage values are not expected to change, analyze which vendor should be selected. So how do we do this? So we have two different cash flow diagrams. First of all is PWA, this one for vendor A, and B for this cash flow diagram. So from this, we computed that the PW for vendor A is negative $45,000 and $36. Vendor B is $41,000 $384. Okay, thus vendor B is selected since cost less in PW terms. That is, PWB value is numerically larger than PWA. So, and further explanation, vendor A is now selected based on smaller PW value. If we have this kind of selection, okay? This means that it's shortened the study period of 5 years, has caused a switch in economic decision. In situations such as these, the standard practice for using a fixed study period should be carefully examined to ensure the appropriate approach, that is, LCM or fixed study period, is used to satisfy the UCL service requirement. So when you use two different methodologies to calculate the PW of two competing values, things may turn around, okay? And it all depends on which standard practice you want to use, whether you want to use a fixed study period or you want to use the LCM method. So I would suggest use both and you will know which one will give you a better benefit. So future worth analysis, FW is exactly like PW analysis, except now we calculate FW, the future worth. Analysis using FW values is especially applicable to large capital investment decisions as a prime goal to maximize the future wealth of a corporation's stockholders. Okay, future worth analysis over a specified study is often utilized if the asset, equipment, a building, etc., might be sold or traded at some time before the expected life is reached. Suppose the entrepreneur is planning to buy a company and expects to trade in within 3 years. FW analysis is the best method to help with the decision to sell or to keep it in 3 years. Here we go. So when we have these kind of problems, when we want to compare machines using future worth analysis at I equals 10%, we have machine A and machine B. The solution is use LCM 6 years, repurchase A after 3 years. Okay, FWA is negative $20,000, FFP 10% 6 minus 9,000, FFA 10% 6 negative minus 16,000, because why? 20,000 minus 4, the salvage value, plus the salvage value $4,000, and you get a value of FWA of $168,000. For FWB, okay, negative $6,000, FFB 10% n equals to 6 minus $7,000 of A 10% n equals to 6 plus $6,000, and you get a figure of negative 101 $157. So from here, we will select B because it gives you the highest value of FW. And you have to note that PW method and FW methods will always result in the same selection if you use the same methodology. Okay, if you are consistent all through the calculations. Okay, this is the example of cash flow diagram if using the FW method. I hope this is crystal clear for everybody to understand how it works. So now we have capitalized cost CC analysis. Okay, many public projects such as bridges, dams, highways and toll roads, railroads and hydroelectric and other power generation facilities have a very long expected useful lives. A perpetual or infinite life is the effective planning horizon. Permanent endowments for charitable organizations and universities also have perpetual lives. The economic worth of these types of projects or endowments is evaluated using the present worth of the cash flow. The basic equation for CC is P equals to A over I. Okay, A is essentially represents the interest of a perpetual investment. For example, in order to be able to withdraw $50,000 per year forever at I equals to 10% per year, the amount of capital required is $50,000 over 0.1%, which is $500,000. For finite life alternatives, convert all cash flow into A value over one life cycle and divide it by I. Okay, that is how we find the solution. Example of capitalized cost for two machines. Okay, compare the machines shown below on the basis of their capitalized cost. Use I 10% per year. Okay, the first cost is machine 1, and we have machine 1 and 2. The first cost is negative $20,000 against negative $100,000. The annual cost for machine 1 is negative $9,000, whereas machine 2 is negative $7,000. The salvage value is $4,000, whereas it's not mentioned here. The life years is only 3, and this is infinity. Right. Convert all machine 1 cash flows into A and divide them by I. So for A, okay, it's negative $10,000 to $20,000 times A of B factors for n equals to 3 minus $9,000 plus the salvage value times A over F, future values, 10% n equals to 3, we get this figure. And for machine 2, you use the CC equation, whereas the negative value of the CC value for A1 is negative $15,834 over 0.1%. We get this figure. And then for CC2, you find this figure, which is negative $170,000. So we realize that select machine 1. Machine 1 will give you a much more better return because it's much more cheaper. So the summary of the important points for this subject is that, first of all, PW method converts all cash flow to present value at MARR. MAR is maximum allowed rate of return. Okay. An alternative can be mutually exclusive or independent. A cash flow estimate can be revenue or cost alternatives. PW comparison must always be made for equal service. Equal service is achieved by using LCM or steady period. And the capitalized cost is PW of project with infinite life, where we can use CC equals to P equals to A over I. Right, that's the end of today's chapter, and I hope you understand. And please read the notes and study again and again for you to understand better for this subject.